Hey folks, welcome to Build Fly Go. So we have a pretty fun series coming up where I'm going to be talking about the avionics, sort of the panel design, doing some of the wiring, really sort of a step-by-step of following the existing documentation out there to, get you from, having a panel blank to a completed avionics in our RV-10. But let's start off with the panel blank. We've been working with Aircraft Specialty on this. They're helping us with the design. They're going to be doing the cutting and the labeling and things like that. But we work together on figuring out where things are going to go and what makes sense and what doesn't, right? And you go through a number of iterations on this. So, first off, for us, we wanted to make sure that we're sticking to best practices. We're not doing anything, too crazy outside of the norm. And also something that fits, right? Like physically fits us. We've seen really tall panels, really skinny panels, thinner panels, thicker panels, things like that for the base material. And we've decided that we actually want to go with the stock Vans size of the panel. So the Vans panel is two pieces, right? There's that front piece, the top piece, and then there's a piece along the bottom that has the switches and whatever you'd like to put there. We've decided to do that in one piece. It's going to be the same thickness, the same material, the same bend along the bottom, but instead of being two pieces of metal that are screwed together, it's one piece of metal that's using the same fasteners, exactly the same fasteners into the airframe. Of course, you need to decide what's best for you. Every time you make a modification, you need to figure out, so what down the road, what does that mean to you, right? Like, what does that mean to structural changes, anything like that? So you need to do that analysis. This is what we've done. So let's take a look at this panel real quick. So it's a fairly common two-screen design. These are two 10-inch Garmin screens, GDU 460s. One on each side. It's probably the most common setup for modern avionics is this, right, with a radio stack in the middle and two big screens on the sides. We did consider doing the two screens next to each other with the radio stack on the right side, but for a couple of different reasons we didn't. We stick with this one. One of them is Mary is a pilot, and she sits in the right seat, and we trade off monitoring duties, right? So she is watching what's going on, or operating the radios, or any of the above. And so for her having a screen that can act as a PFD in front of her helps safety, right, for us. And we fly this setup as well in the RV-9, and it has served us really well. We're really happy with it. What else do we have here? So we have a Garmin G5 on the left side. The G5 integrates really well with the G3X system. I really like that the knob on the G5 turns into your altimeter setting, the barometer. So I always have one knob that can change that. But the G5 is independent, right? It's Garmin tells us that it's a separate software stack. It's got its own battery, so it can run entirely independent from everything else. But it can back up the screens, right? It can run the autopilot, for example. So things like that. So it adds a layer of redundancy that we feel is important on an aircraft that's going to be flying in IMC. The G5 as a backup. You'll notice in the stack there's the autopilot head on the top. It's the GMC 507, just like in the RV-9. I like having it up top. It just feels like the right spot. It feels like ergonomically it makes sense for it to be up there, because it's not something I'm going to bump into, right? Like I have to actively be going up there to change things, so I don't want it sort of in the way. Below that, there's a cutout. This is actually going to have the GMA 245 audio panel and a GTN 750 XI. The audio panel, the question I get the most, one of the questions I get most is, are we doing remote radios? Are we doing remote audio panels? Right, like what's going to be hidden and what's going to be visible. The for the G3X system can have a set of remote radios and a remote audio panel, and in fact, the even if you have the non-remote, the panel mount audio panel, you can simulate on the screen, or you can have buttons for a lot of the audio panel functionality on the screen. So what I did was I went and configured my G3X in the RV-9 to show me the audio panel buttons on the screen. And I did a few hours of flying where I did not use the physical knobs, right? I used only the buttons on the screen. And I found that that works really well. But I really do prefer having physical buttons for that. It's just a personal preference. What works for me might not work for you, etc., vice versa. um, so figure out what's best for you and then decide. Right? There's only so much space here, and then decide what's going to go. We did want to go with a 750 this time around instead of a 650. If you remember, we have a 650 in the RV9. There's a 650 and then a GTR 200 below it. We wanted to do a 750 because this plane is a little bigger, right? Like it's definitely wider. So the right side screen, the right side GDU over here, is a little further to the right than in the RV9. So having another display right in the middle in my eyesight that can display things like traffic or weather or whatever you configure it to display, right? The flight plan, for example, is usually what I have up in the 9 actually. Having a screen that can display all of that in my eyesight, in my eye line, I think was valuable. It was a valuable upgrade for us. You'll notice that we won't have, or I guess maybe you can't see because it's not there, we won't have a GTR 200 here. We are doing a second comm. We're doing the remote comm in this case with the GTR 20. We're still trying to figure out where we're going to place that, if it's going to be behind the panel or in the back behind the rear baggage bulkhead. Stay tuned. We'll be figuring that out in the next couple of months. But it's not a physical audio I'm sorry, a physical panel mounted radio. We would have preferred to have it here, but there's only so much space. And with the design that we chose to keep the van's panel size and the van's panel, layout, we've decided that, that was one item that we could lose. And of course, the G3X has radio buttons on it, and you can do all the tuning and all that kind of stuff. And I did the same thing, right? Like I tuned it, I configured it to do local tuning, local control over the GTX. I'm sorry, GTR. And I found that it worked, in my use case, in my, sort of user interface experience, it worked really well for us. So happy with that choice. Let's take a look at a couple of the other things. So you'll notice that there's two sort of rectangles over here. If you remember on the RV9, these are the master warning and master caution indicators. They're just LEDs with a little backlit label that say one is red, one is yellow, master warning, master caution. One of them is also a button. It is the MFD revisionary mode button, which forces, if I hit that button, it forces the MFD into a PFD. This does also happen automatically. If the MFD notices that or if it loses communication with the PFD, it will switch automatically to PFD mode. But you can also force it into that mode, which we actually use when two pilots are in the aircraft. That button is usually pushed because both pilots want to have a PFD in front of them. If you've seen my flying videos, I usually fly with a split screen anyway, with a PFD on the left side and a moving map on the right side. So it won't really change my configuration at all. It just makes it so that the other screen is doing that. Usually when it's just myself flying, I have the other screen in sort of a zoomed out map so that I can see sort of more weather and more things like that and what's going on. On the N number on the top left above the PFD, and the passenger warning, the FAA required passenger warning on the right side above the MFD. Taking a look on the left side, you'll notice that we are using Pmags again. We use Pmags on the RV-9 and we're very happy with them. And we're using them again in the RV-10. Emag has released a set of mags for 6-cylinder engines, and they've been on the market for a little while now, and they've got a good amount of hours under their belts, and they're doing great. So I'm excited to be using those as well. And full disclosure, I'm very upfront about this. We have sponsors, and they are one of our sponsors, so they did help us out with some of that. Below those switches, so the Pmax switches, I have this set up. You'll notice that this panel in general is very similar to the 9. So I have this set up so it's the enable switches on the bottom for left and right, and the external power switches left and right on the top. And the external power switches are really for my ground run-up testing. They stay on in flight, and the enable are just magneto enable switches, right? Just like a key switch, they're just toggle switches. I liked this layout. It's worked really well for us so far. Below it, there's a key switch and a push button start, which just is the starter button. The key switch enables the starter button. You'll notice sort of a weird number 8 figure here. This is because we hadn't decided where the air vents were going to go on this airplane, right? If you notice on the RV-10, the air vents are not in the panel. They're actually below the panel. They're a plastic piece. We chose not to use the plastic air vents, and we went with a nice set of metal air vents. And when we cut the plexi version of this panel, we asked Aircraft Specialty to make us, they have an option for cutting a plexi panel. We asked them to cut 2 circles into the panel, so that we could put it in both spots and see how it fits. I'm actually pretty happy to report that on the top spot, it fits great. I'm pretty happy where that is. It's not in the way, so we're not extending the panel with this sort of semicircle on the bottom here. We're going to miss out on an opportunity to put a little logo, but we're not extending the panel, so it's going to be exactly the same height as the van's panel. On the bottom here, this is actually the bend. This is going to extend all the way over to match the van's bend. Let's take a peek at switches real quick. Master switch, regular master switch. IBBS, we have TCW Tech IBBS batteries, as you saw in a different video. TCW Tech is one of our sponsors, thank you. And this enables the batteries. We'll do a video later on about the electrical system in the airplane and the redundancy there. There are actually 2 IBBS batteries for different sets of avionics. And they are switched by one double pole, double throw switch. I think I said that right. So yes, a little bit of a single point of failure here, but switches, switches don't really go bad. I might be convinced to make this 2 switches, maybe. We'll see. 2 alternators. Plane Power is has provided alternators. Thank you, Plane Power. So we're using the regular Plane Power alternator that Vans ships. Nothing new there, nothing different. And we're using the Plane Power FS1-14, please correct me if I'm wrong, which is their backup alternator that goes on the accessory pad on the back of the engine. I'm going to do a video on that as well later. Boost pump, pitot heat. We're using the Garmin GAP pitot heat, the regulated version. Check out I think it's the RV-9 modifications video where I talk about why I really like the regulated pitot. Highly recommend that over just the on-off one. Strobe, nav, and taxi and land lights. These lights are the fly LEDs. I love them. They're in the 9. Everybody talks about how incredibly bright they are. It's just a good product. I don't know what else to say. It's a good product. Flap switch up here. It's a momentary up, momentary down. This is unfortunately a fairly expensive switch. There's not a lot of options for switches where the toggle itself doesn't rotate. So there's a flap switch there. This is the oil cooler potentiometer to open and close the oil cooler baffle to allow more air to come in. more or less air. We live in Wisconsin, so we do need to vary the amount of air that goes through the oil cooler, otherwise it just cools way too much. Aux Fuel Pumps, we do have um, extra fuel pumps, fuel tanks in the wings. This was a choice that we made for some of the really long distance trips that we're planning on doing, and we wanted more fuel on board, so this was a choice that we made. Again, if you're going to make modifications like that, please think it through. Please talk to experts and engineers about different weights and where things are going to go. Right? Just because we've done it doesn't mean it's a good choice. Right? Like, this is a personal choice. Make modify the plans at your own risk. Anyway, so 2 fuel pumps switches. Then moving on, this is exactly like in the 9, right? There's one switch over here. Up is red, bottom is white, which changes the dash lighting from red to white. The potentiometer right next to it is the dash one, just intensity on that. This one says Avionics. Is actually not going to say, we haven't decided what's what here. I believe these are going to be the cabin lights. If you've seen the last set of videos, or maybe there's going to be videos coming out, on the overhead panel that we created with LED lights built into it, those lights will also have options over here. And we got some really cool looking potentiometers for these. The potentiometers themselves are lit up with RGB lights. So the little potentiometer is going to have the same color as the light that's up there. Anyway, cabin heat, front, back. They're the TCW Tech actuators that you saw in a different video that's already been posted. Top to bottom, just the regular ELT panel. Alternate static port. So basically this vents the static lines to the cabin. So if both static ports get plugged, we can vent the static port. Emergency O2 basically bypasses, there's a mode in the Mountain High built-in oxygen system where it can bypass the electronics, and then the regulator in the back just goes to constant flow. It's just an emergency switch. In case airplane loses power or something happens, we still have oxygen. Of course, the oxygen endurance is going to be lower because then it's not pulse delivered, it's constant flow, but it gives us something. Down here is going to be the Mountain High panel, control head panel. There is a Garmin GSB-15 USB power right here. We decided to go with the 2 USB-C model, right? There's 3 options. There's the 2 USB-A model. I don't even have a USB-A. Here, this is what a USB-A looks like, right? Like, it's the standard USB. So you can have one of those that is 2 of these, which is sort of the previous generation of USB plugs. You can have one that is one of those and one of the new USB, right? Like the little oval one, and that's the modern one. So you can have 1 and 1, 2, or 2. And we went with 2 because we're building a modern airplane, and pretty much all of our devices use this nowadays, right? Like, I don't have any devices that use the old plug anymore. And you can get more power out of this device or this USB plug type, so it will charge things faster. So the GSB-15 right there. And then on the right side, you'll notice there's a little cluster of, there's 4 breakers and a switch. We're using the VPX electronic circuit breaker system in this aircraft. So it's all integrated with the G3X system and all that kind of stuff. But as you've probably heard me talk about, I don't like single points of failure, especially for systems, that control everything. And though the VPX does have individual redundant boards inside it, I don't think they're actually separate boards, but they're separate paths on the boards. So there's some redundancy in there, but we decided to also have a OCRUD switch, if you will, which entirely bypasses the VPX and applies power to the PFD, the AHRS, the GEA, which is the engine monitor, and the G5. So all of those devices actually have a second power input that you can use. So that second power input is plugged into the breakers over here, and which is powered by this switch. This is going to be a guarded switch, not a guarded switch, sorry, a locking toggle. So you have to pull on it. I'm not. Yeah, you can see that. You got to pull on it. Don't want to break this. um, to turn it on, and it is rated for I believe it's 15 amps or 20 amps. It's a burly switch. And of course, there's a fuse right in the back. There's a fusible link is what we're going to be using. And that way, if everything falls apart, I can still power those avionics, right? Like the critical avionics, critical flight avionics, off of the battery, the main battery, and the alternators if they're still running, right? Like I plan for these crazy scenarios and just add this redundancy. I'm very particular about adding redundancy, but trying not to add complexity, right? So this is a very simple system. I'm not using a relay, using parts that are resilient, right? It's just a switch. It's a well-known burly aviation switch, and aviation breakers, and like simple. We know it works. It'll be good. But yeah, so this is just a quick overview of our panel, and where we're going with this. We'll talk later about avionics choices, why I chose one versus the other. We'll probably do that either in the RV-9, where I can point at things and talk about how we made some of these choices, or if we do it later in the build, we can do it with this panel when it's complete. We'll see when we get to that one. Do reach out, ask us questions. There's going to be wiring videos. We're going to talk about the wiring. We're going to follow the Garmin manuals to do all of this installation. I'm looking forward to those. But let us know what you want to see and what's interesting to you, and let's take it from there. All right. Thanks for watching.